Hey everybody, welcome to Programming with Benu. This is Benu Bali, and in this video I'm gonna talk about design patterns a whole bunch. What are design patterns? Why should we use them and how should we use them? A quick and simple answer is that the software design patterns are strategies for solving common problems in software engineering. But to answer these kinds of questions, we need to understand what is a design pattern. So let's find out. Christopher Alexander says each pattern describes a problem which occurs over and over again in our environment and then describes the core of the solution to that problem in such a way that you can use this solution a million times over without doing it the same way twice. Even though Alexander was talking about patterns in buildings in cities, what he says is true about object-oriented design patterns. In the Gang of Four's opinion, each design pattern focuses on a particular object-oriented design problem or issue. It describes when it applies, whether it can be applied in view of other design constraints, and the consequences and trade-offs of its use. And Steve McConnell believes design patterns provide the cores of ready-made solutions that can be used to solve many of software's most common problems. Some software problems require solutions that are derived from first principles, but most problems are similar to past problems, and those can be solved using similar solutions or patterns. The design patterns are descriptions of communicating objects and classes that are customized to solve a general design problem in a particular context. The design pattern identifies the participating classes and instances, their roles and collaborations, and the distribution of responsibilities. Okay, now we kind of know what we're talking about. So let's dive into design patterns. In general, a pattern has four essential elements: the pattern name, the problem, the solution, and the consequences. The pattern name is a handle we can use to describe a design problem, its solutions, and consequences. It lets us design at a higher level of abstraction. The problem describes when to apply the pattern. It explains the problem and its context. It might describe specific design problems, and it might describe class or object structures. The solution describes the elements that make up the design, their relationships, responsibilities, and collaborations. The solution doesn't describe a particular concrete design or implementation because a pattern is like a template that can be applied in many different situations. Instead, the pattern provides an abstract description of a design problem. The consequences are the results and trade-offs of applying the pattern. The consequences for software often concern space and time trade-offs. They may address language and implementation issues as well. Since reuse is a factor in object-oriented design, the consequences of a pattern include its impact on a system's flexibility, extensibility, or portability. We classify design patterns by two criteria. The first criterion, called purpose, reflects what a pattern does. Patterns have either creational, structural, or behavioral purpose. Creational patterns concern the process of object creation. Structural patterns deal with the composition of classes or objects, and behavioral patterns characterize the ways in which classes or objects interact and distribute responsibility. The second criterion, called scope, specifies whether the pattern applies primarily to classes or to objects. Class patterns deal with relationships between classes and their subclasses. Object patterns deal with object relationships. Almost all patterns use inheritance to some extent, so the only patterns labeled class patterns are those that focus on class relationships. By the way, the most patterns are in the object scope. Creational class patterns differ some part of object creation to subclasses, while creational object patterns differ it to another object. The structural class patterns use inheritance to compose classes, while the structural object patterns describe ways to assemble objects, and behavioral class patterns use inheritance to describe algorithms and flow of control, while the behavioral object patterns describe how a group of objects cooperate to perform a task that no single object can carry out alone. There are other ways to organize the patterns. Some patterns are often used together. For example, as you can see in here, composite is often used with iterator or visitor pattern. Some patterns are alternatives. For example, the prototype pattern is often an alternative to abstract factory pattern. And some patterns result in similar design even though the patterns have different intents. For example, the structure diagram of composite and decorator are similar. Okay, in here we have creational patterns and their intents or definitions. And by the way, there's a thing about the singleton pattern. A lot of people consider the singleton pattern to be an anti-pattern. So I will cover up this pattern or anti-pattern in the next video and talk about it more in detail. And these are other creational patterns that you can find out in more other sources or Wikipedia. And these are structural patterns. And other structural patterns. These are behavioral patterns. And their definitions or intents. And these are other behavioral patterns. I'm gonna talk about more patterns and examine all of them in the next videos, so definitely check that out. Thanks for watching.